are throwing two dice simultaneously, okay, or two coins simultaneously, or three coins even. So up till three coins, you will get questions.
Okay, ma'am.
Okay. So we discussed about cards, right? Cards questions we have done. Okay. So let us do when two coins are tossed together. So what are the possible outcomes in this case? Right. So you can just note it down at least once. You should know. After that, you will get familiar. So you will remember the number of outcomes. But let us see what are the outcomes actually. So when two coins are tossed, so there can be possibility that the first coin is head and the second coin is also head, right?
Yes, ma'am.
First is head and the second coin is tail.
Yeah.
Now the second coin is tail, the first coin is head, or both the coins are tail. So I think these are the only possible outcomes, right?
Yes, ma'am.
Yeah. So four. So total number of possible outcomes are actually four in this case. Clear?
Yes, ma'am.
Four possible outcomes. Okay. Now next, let us see when three coins are tossed together. Okay. Now what can happen? See, the first coin is head, right? Second coin is also head. The third coin is also head. Correct?
Yes.
Okay. Now what can happen that the first so the combinations will be like this. Like first coin is head, right? In four cases.
Okay.
Tail. Okay. Now it can happen that first coin is like head and second is tail, right? Like first we are keeping same. Now second coin is head, third is tail. Now second is tail, third is head, right? And
Yeah.
both second and third are tail. Okay, now with tail. Okay, so first coin we are, let's say it's all tail in this case, and second coin is head, third is tail, right? Now second is tail, third is head. Or mm, wait, I mean these are correct, but I think I should write it in a same pattern. So let's say they both are head, right? Now one is head, other is tail. Then one is tail, other is head, and both are tail. So these can be the 8 cases when two coins are tossed simultaneously. Yes, Arshia, can you hear me? Please unmute your mic, Arshia. Martin, can you hear me? Okay. So how many total number of outcomes? Is equal to 8, right? Arshia, I can't hear you. So please note it down. Okay, done. Manha. Okay, Arshia, you are traveling. Anyway, Arshia, at least you can take screenshots, right? So I'm saying that if so far in this exercise there were questions where single coin was tossed, okay, or single die was thrown. But now we will have questions where two coins are tossed, basically simultaneously, or we say together we are tossing them, right? So at the same time. So these are the four possible outcomes, like both are head, first is head, second and tail and head and tail, tail. So only 4 outcomes can be there, possible outcomes. Now, if 3 coins are tossed, so these are the 8 outcomes in this case. Just a minute, Martin is actually trying to join. He's having some network issue, I think. Okay, anyway. Now there is another case where 2 dice are thrown. Now what will happen? Yes, Mana, are you there?
Yes, ma'am.
Okay. Now on a dice, you know, there are numbers from 1 to 6, right? 1, 2, 3, 4, 5, 6, or dots are there or numbers are there. Now, if 2 dice are thrown together, so what can be the possible number of outcomes? Let us see. See, on a coin, there were only 2 cases, either head or either tail. And so we were making combinations of that only. Now here we have 6 faces, right? So it can happen that the first dice is showing 1, right? Second dice also showing 1. So this can be one combination. Now first dice is showing 1, second is showing 2. Then 1 and 3, right? Then 1 and 4. Then 1 and 5. And then 1 and 6. So this is one of the possibility, right? Now, second combination can be that the first dice, let us fix this as at 2. So if like we are actually writing these cases where the first dice is showing. Yes, Martin. Am I audible?
Yeah.
Okay. So Martin, I'm just discussing. So far we were doing questions where only 1 dice was thrown, right?
Yeah.
Now,
Yeah.
if 2 dice are thrown simultaneously, so what are the possible outcomes? I'm writing that. So these are the cases where the first dice is showing 1. Now, if the first dice is showing 2, second can show 1, right? Then 2 and 2. Then I can have 2 and 3 on the second dice. Now 2 and 4, 2 and 5, and 2 and 6, right? Okay, now first dice is showing 3, second is showing 1. So 3 and 2, then 3 and 3, 3 and 4, 3 and 5, 3 and 6, right? Now first dice is 4, second is 1. So 4 and 2, 4 and 3, 4 and 4, 4 and 5, 4 and 6, right? Now first dice is 5, second is 1. Now 5 and 2, then we have 5 and 3, 5 and 4, 5 and 5, and then we have 5 and 6, right? Now first dice is 6, and this is 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6 and 6. So can there be any other possibility? No. Right. So at least once you should write this in the copy. You don't have to write all this in every question, but you should know what are the possible outcomes. So how many of them in total? Like you have 6 this side and then 6 this side. So 6 into 6, how many?
36.
36. So total possible outcomes in this case are 36. Now let us come to question number 22 of NCERT. Written all of you? Okay. 22, right? Now 2 dice, 1 blue and 1 gray are thrown at the same time, right? Complete the following table. So the event actually of which you have to find the probability is this, like sum of 2 dies, right? Okay. Now your event is this, like first they have done that you want the sum as 2, right? So how many cases can be there? Like for example, on the first die, it is 1, right? And the second die is also displaying 1. So now the sum will become 1 plus 1, that is equal to 2, right? Now if I take first die 1 and the next number 2, so the sum actually becomes 3, which I don't want. I want only sum 2. So this is the only case, isn't it? Yes?
Yes, ma'am.
Okay. So number of favorable outcomes are how many here? Only one, isn't it? Right? Which you can, I mean, write, you can write the combination in case you forget that how I'm getting it. So it's actually this combination, 1 and 1, right? So number of favorable outcome is only 1. So the probability of sum 2 is actually my number of favorable outcome is only 1. Number of possible outcome is 36 as we have seen. So this is the probability that the sum is 2. Right? Okay. Now next is that you want sum 3, right? Sum has to be 3. So what can be the possible outcome? Like my first die, if first die is showing 1, second should show 2, isn't it? Then only I'll get sum 3. Yes, Martin?
Yeah, yeah.
So this is one case. Now another case is first is 2, second is 1. Here also I get sum 3. I think there is no other case like that. If you look at the table I gave you, right?
Yeah, ma'am.
Yeah, so only 2 are there. So you write number of favorable outcomes is equal to 2, right? And if you want to write, you can mention these combinations 1, 2 and 2, 1, right? So the probability that the sum is 3 is favorable outcomes are 2, total are 36. So you can reduce it to simplest form. It will become 1 upon 2 into 1 and then 16. So 2 into 8, 16, 1 by 18. Okay, now, okay, I'm just sitting here. Now you please try to complete this table, all of you. So I'm giving you time, and where you get stuck, just let me know. Right? So next sum is 4. Now please try to do it. Yes, Martin, what is the probability that the sum is 4?
1 by 9.
1 by 9. Okay, how many favorable outcomes are there?
4,
Okay, which one?
2, 3, 2, 2, 1, 3, 2, 2, 3.
2, 3. Here the sum is 5, Martin.
Am I what?
You want sum 4, but 2, 3 will give you
I,
5.
I told 2, 2.
Okay, right. 2, 2, good. And
1, 3, 3, 1.
1, 3, okay, and 3, 1, right? That's it. Okay.
Yeah. Then
Yeah.
again 2, 2.
Yeah, so it will be 3 by 36, right?
Yeah.
So it will be 1 upon 12.
Yeah.
Yes, Mana, what is the probability that the sum is 5?
1 by 9, ma'am.
1 by 9. Yeah, that is correct. Please complete the table.
Okay.
See, I show you something here. Look at this pattern I gave you, right? So you start like this. So this combination will give you sum 2, right? Then this one will give sum 3, right? Then this give you sum 4. Now the next, this will give you sum 5, right? Then this gives you sum 6. Like if you write it properly, my lines are a little bit here and there. And all these combinations, the diagonal ones, they give you sum 7. So like that, you can find out the possible number of cases, isn't it? So next line you are going to have sum 8 here, right? Then you can see the sum is 9 in this case. Now the sum is 10, sum is 11, and the sum is 12. Is this clear? Yeah. Yes, Mana, completed. Martin, completed the table. Martin, unmute yourself, please. Okay, Abdullah, you're also here. Please
Yes.
unmute yourself. Okay. So, Abdullah, just a quick recap I'm giving. I'm on the chapter probability, as you know, right? So far we were actually doing questions where only one coin or only one dice was thrown. So today I'm taking up questions where two dice or two coins are thrown simultaneously. Okay. So at least you take a picture of this screen. So these are the possible cases, Abdullah, that the first, as you can see, like first dice is having number 1, the second dice can also have number 1, right? Or the first dice can have number 3, the second can have 4. So any combination can be there, and the last is that both are 6 6. So these are the possible 36 outcomes in this case. Is this clear? Yes, please speak up. Abdullah, unmute yourself, please. It's okay if some noise is there, just don't worry about it. Please unmute yourself. See, I always say the classroom has to be interactive. If you people will always remain on mute, how we will interact with each other and how will you ask questions? How would I
Yeah,
know
ma'am,
what
I
are the
understand.
questions in your
Yeah, ma'am,
mind? So it get difficult for me as well to teach you like this, right?
I understand. Yeah.
Okay, anyway, you take a picture of this screen also, Abdullah. If two coins are tossed together, so these are the four possible outcomes, right? The first coin is head, second coin is also head. First coin is head, second is tail, and like that, right? And if three coins are tossed together, so there can be 8 cases. So 8 possible outcomes can be there. Please take a screenshot. Okay, I hope you have done it. Now next. So there's a question, Abdullah, question number 22 of NCRT, right? So they are asking that find the probability, for example, the sum is 5, right? So you have to see how many number of favorable outcomes are there. So if you look at these cases, this one, so you can see this is having sum 5, 4 plus 1, 5, then 3 plus 2, 5, 2 plus 3, 5, and 1 plus 4, 5. So I have 4 favorable outcomes out of 36. So my probability is 1 upon 9. So like this, I can find probability of any sum. Okay, let's move forward to the second part of the question. So as you can see in your book, a student argues that there are 11 possible outcomes. Okay. Therefore, each of them has a probability 1 by 11. So do you agree with this argument? So on a dice, right, you have seen that there can be cases where the sum is 2, where the sum is 3, or I can write it properly, like sum is 2, sum is 3, sum is 4, 5, 6, 7, 8, 9, 10, 11 and 12. So these are the possible sum. Okay. So one student is saying now as they are 11 in number, so every sum should have a probability 1 upon 11. What do you think about it, Martin?
Yes, ma'am.
Is it correct?
No, it's not.
Why? Can you explain?
Because the probabilities to 1 by 36 and
Yes, very good. So as we have just found out, right? We have solved it and we have seen that here the probability in the case of 2 was actually 1 upon 36, right? And in case of 3, it is like this. This is how you're going to answer this question, right? Uh, and you can write probability here, corresponding probability, right? So this is 1 by 36. Then you got 1 by 18. In case of 4, you got 1 by 12. This gives you 1 by 9. In case of 6, it was 5 by 36, right? This is 1 upon 6. So you can check your answers also if something is wrong. So 5 by 36. Ninth is you got 1 by 9. Here you got 1 by 12. This is 1 by 18. And this one is 1 by 36. Just 1 minute. Right. So we can see every sum is giving us different probability. So here all my events are not equally likely. So as you can see, there are no equal chances of every sum to happen, right? So you write all the events here are not equally likely. So I hope you understand the meaning of equally likely, right? In the bracket, you can write as the probability is different for every event to occur, right? So therefore, this statement is incorrect. Fine. So the probability is not 1 by 11 for every case. Or you can say it is an incorrect argument. Okay, next question number 23. A game consists of tossing a 1 rupee coin 3 times, okay, and noting its outcomes each time. So you can see here a coin is being tossed 3 times, okay. So can we write total number of possible outcomes? How many are there?
can be any order.
8, right? As we have seen. So H, H, H. Then we have H, H, T. Then we have H, T, H and H, T, T, right? Then we have T, H, H. Then T, H, T. T, 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 H. And then T, T, T. So these are the 8 cases. Hanif wins if all the tosses give the same result. Okay, that is 3 heads or 3 tails, and loses otherwise. Okay, so what are the number of favorable outcomes for Hanif?
2.
Yes, 2. So according to the question, if this comes, right, same on every coin and this comes, only then he wins, otherwise he lose. So only 2 cases are we have like this. So favorable outcomes are 2. Clear, Martin? Calculate the probability that Hanif will lose the game. Okay, sorry. So will lose the game means the remaining are your favorable outcome. So 1, 2, 3, 6 are your favorable outcome in this case. Understood?
Yeah.
So probability that Hanif loses the game will be 6 and divided by 8, right? Or you can write it 3 by 4. You can also do it like this, like if you want first, you can find probability to win the game, right? So in these 2 cases, he is going to win, right? So the probability here is 2 by 8, which is 1 by 4. So the probability of winning will be, so there are only 2 cases, either he win, either he lose, right? So lose the game can also be found like this. Total probability ultimately is 1, right? So winning probability is 1 by 4. So the remaining is losing probability, correct? So here you take LCM 4. So it will be 4 minus 1. That also gives you 3 by 4. So both way you can find it out. Okay, next question. A dice is thrown twice. Okay. What is the probability that 5 will not come up either time? Good. So this is an important question. 24. So he's saying a dice is thrown twice. So first of all, write the total number of possible outcomes, right? As we know, we have 36. Okay. So he's saying that 5 will not come up either time. So what we will do is we can find so let us see the cases. If I go back here, okay. So let us see where 5 is coming, right? So he's saying that neither on the first die, neither on the second die, 5 should not come. So I can spot 5 here in this case, right? If I look at this row, right? This column I can see a 5, and this column I can see a 5 on one of the die, correct?
Yes,
So
ma'am.
if you count them, how many cases are these? So 6 here, right? 6 this side, and then 5, because this will be otherwise double counted. So 1, 2, 3, 4, 5. So 6 plus 5, how many? In 11 cases, I'm getting 5, right? Yes, Martin, clear?
Yeah.
So if I subtract 11 from 36, so I'll get the cases where 5 is not coming, correct? So in this question, I think you have to draw that table again, all the possible outcomes, and then you can show where the 5 is coming. So you can write that total outcomes where 5 comes up. They are 11 in number, right? So that means total outcomes where 5 will not come up. So that will be total 36 and minus 11. How many are there? 6 minus 1, 5, 3 minus 1, 2. So 25 cases are there. So the probability or you write let E is the event that 5 will not come either time, right? So I'm giving it a name E. So the probability of E is again the formula, number of favorable outcomes. So please make a habit of writing the formula in every question. Sometimes I skip it, but you have to write upon total number of possible outcomes. Right? So number of favorable outcomes are now 25 because you want this probability. So 25 and then total were 36. So this is the probability. Manha done.
Yes, ma'am.
Martin done.
Yeah.
Okay. Now next part, second part. 5 will come up at least once. Now there's a term which is very, very important and it is called at least. Now pay attention to it. So you will come across two terms in the exercise. One is at least and one is at most, right? Right? So please understand what is the meaning of it. If you want to get at least 5, right? At least means the minimum number of 5, I mean 1 5 has to be there. Am I right? So for example, 5 and 1. So this is like one case where you are having at least 1 5 and you can have 5 5 also because it is also having at least 1 5 is this is having. Am I right?
Yes, ma'am.
So do you understand the meaning of at least one?
Yeah.
Okay, so can't we just directly take 11? 11.
No, this is just two examples I'm giving. I'm not saying these are the possible outcomes. I'm
Okay.
saying at least means like 1 5 has to be there, right? So you can
Oh,
write like 1 5 has to be there. More than 1 5 can also be there. Understood? Right? Now, at most means if I say that it should have 5, sorry, 5 will come at most once. Let's say 5 will come at most one, right? If this is the question, let's say. Now, at most means that the maximum number of 5 can be only one, right?
yeah. Maximum, right?
Maximum number of 5, or you can say 5, can only be one. So that means like there will be combinations where you have like 1 and 5, right? And 2 and 5 and like this. But 1 and 2 will also come under this. That means maximum number of 5 has to be 1, but it might not have any 5. Understood?
Yeah.
So here you can write that, okay, this first point I have wrote, maximum number of 5 can only be 1. Cases where you do not have 5. Will also be included here. See, if I write, let's say 2 and 4, right? So it is not having any 5. So I can say it is falling under at most. So here at most means the maximum number of 5 has to be 1. It can be 0 also. Clear? Manha, understood?
Yes, ma'am.
So it can be 0 also. Here actually the maximum limit is set, right? At most means actually maximum limit. So you can go below the maximum limit, but the maximum limit is this. Now at least actually means minimum limit. So I think this is the short word to remember. Right? So at least 1 5 has to be there. Now it can be 2 5, but at least 1 has to be there. And in this case, only 1 5 has to be there. It can be 0 5 also, like there is no 5. Understood? So here actually this case will also be included where you are having 2 5s. And here this case will also be included where they are having no 5. So as an example, you can write it. So let us come back to the question now. Second probability is 5 will come at least once. Okay, so at least one time you have to get it. So how many cases are there? If I write this row, let's say 5 1 and then 5 2 and then 5 3 5 4 and you have then 5 5 and 5 and 6, right? And then here I would have in 1 and 5, then you have 2 and 5, 3 and 5, 4 and 5, and then 4 and 5, and then 5 and 5 is there, right? Yeah, so these are the cases, right? Now how many are having at least 1 5, right? So this is having at least 1 5, 1 5, at least 1 5, at least 1 5, at least 1 5, at least 1 5. Now at least 1 5, at least 1 5, at least 1 5, at least 1 5. What about this?
11, right? 11. Yeah. Only at least 1 5 more. So,
So
yeah,
this will also be included, right?
yes, ma'am.
Because at least 1 5 is there. So how many favorable outcomes here? 11.
Yeah.
Okay, 11. So the probability that 5 will come up at least once. So this is 11 divided by 36. Okay, next question now. If which of the following arguments are correct and which are not correct, give reason for your answers. Okay, first, if two coins are tossed simultaneously, there are three possible outcomes. Two heads, okay, two tails, and one of each. So that means head and tail and head, right? Okay. For each of these outcomes, the probability is 1 by 3. So we have to check whether it is 1 by 3 or not. So total number of possible outcomes, as we know, is equal to 4 in case of coin. So basically there are three combinations here. One combination is that you are having both same, right? Both head, both tail, and this is like another combination where one is head and another is tail. So let us find out the probability of each. So the probability of getting two heads. So only one favorable outcome is there, right? Out of 4. So 1 by 4 is the probability. Similarly, probability of getting two tails. Is again like one case is there out of 4, right? And what can I write? Probability of getting one head and one tail. So I have two cases like this. So 2 by 4, or I can say 1 by 2. Now, in each case, the probability is not equals to 1 by 3. In the question, they are saying, therefore, each of these outcomes, the probability is 1 by 3, right? So this is also not equal to 1 by 3. This is also not equal to 1 by 3. This is also not equal to 1 by 3. So therefore, we can say the given statement is incorrect. The probability of these outcomes is not 1 by 3. Okay, next, second part. If a die is thrown, there are two possible outcomes, right? An odd number or an even number. Therefore, the probability of getting an odd number is half. So we have to check whether it is half or not.
Now could you go back?
Yeah, sure.
Yeah, ma'am.
Okay. So in the second part, like only one die is being thrown, right? So what are the cases? So like you can get 1, you can get 2, 3, 4, 5, and 6. Only these cases are there. So total number of outcomes is equal to 6, right? Okay. So you have to check the probability of getting an odd number. So how many favorable outcomes are there? Like out of these, odd numbers are 1, right? 3 and 5. So number of favorable outcomes are 3. So the probability of getting odd number is 3 outcomes divided by total outcomes. So you can say it is 1 by 2. And also what are the even numbers here?
4 and 6.
Yeah, so 2, 4, and 6. So again, number of favorable outcomes are 3. Okay, so the probability of getting even number is 3 divided by 6, again half. So in both cases, I'm getting my probability half. So therefore, the given statement is correct, right?
Yes.
So hence, the given statement is correct. So we have completed the chapter probability, and I'll send you some assignment sheets on probability, right?
Okay.
And I also advise you to practice more questions from some additional book apart from NCRT. And then in the next class, I'm planning to start triangles again, right, Martin? Because it's a long time we have done that chapter.
Yeah, true.
So you must have forgot it. So it will be a revision also, right?
When are we gonna start now?
Sorry, I'm in next class on Thursday, right?
Yeah.
Yeah, okay. So we will be doing triangles. Okay, then you can leave. I have my next class now. Okay, bye.
Thank you, ma'am.